Hello all, in today's lesson we will learn Radix sort. So let's see what we are going to learn today. We'll learn the concept of Radix sort with one example. Then we'll see what is the time complexity of the Radix sort with the help of the algorithm. And then we'll see what is the space complexity of the algorithm. So let's talk about some important points related to the Radix sort. Radix sort is a non-comparison algorithm. It's also known as the stable algorithm. As we know that we have two types of sorting algorithms. One is the comparative sorting algorithm, in which we perform comparisons among the elements, and the second is the non-comparison algorithms. These are also known as linear sorting time algorithms. So this is a non-comparison sorting algorithm. It is used to sort numbers only, and we sort the numbers from the least significant digits to the most significant digit, right? So in a number, let's say if this is 453, so the least significant digit is this 3. Then we move towards the left hand side and 4 will be the most significant digit. So we start sorting from the least significant digit, and then we move, we'll start with ones, then we'll tens, and then hundreds, and so on. So in this, the sorting of the numbers begins from the least significant digits and to most significant digit. That is why here we have importance of the number of digits and the base of the number we are using. The next is we use counting sort as subroutine for the sorting. So once we select a digit, let's say if we are going to sort on ones place, then we sort with the help of the counting sort, that is with the help of a stable sort again. So this is these are the three important points related with the Radix sort, and we'll see the algorithm. Before we talk about the algorithm, let's see how Radix sorting is done with the help of an example. So if we see that this is an array with all numbers, the first step is to find out the maximum number. So we need to find out the maximum number from the array so as to identify the number of digits or the number of passes we will be requiring. So you can see here the maximum number is 502. So that means this 502 is maximum, which is containing 3 digits. So it's a 3-digit number. That means we have to perform 3 passes. And we need to consider each number as a 3-digit number. So this is already 3-digit number, it's 34. So complete this to 3-digit number, we need to add a 0 before it. So now it's a 3-digit number. Like in the case of 04, so we have 004, it's a 3-digit number. Then it's 066, and then it's 090, 085, 055. Now we can see that all the numbers are 3-digit numbers, and we need to perform 3 passes. So we will begin with the pass number 1. In the pass number 1, we'll pick up the ones digit and we will sort these elements on the basis of ones digit with the help of the counting sort. So let's consider the ones digit. Here we can see this is 6, this is 4, this is 4, this is 2, this is 0, this is 5, this is 5, and this is 0, right? So if we are going to sort them, so what will be the next sorting criteria based on ones digits? So you can see the smaller numbers are, this is 0, then we have 0. Whenever we have both same numbers, like this is also 0 and this is also 0, then we'll not pick this 90 ahead, we'll pick this 160 ahead, because this is already before in place comparatively to 90. So we'll use 160 first, then the next number will be 90. I'm writing here let's say 90. So this is 0 and 0. After 0 we have, this is 2, so we will have 502, because we are sorting on the basis of ones place. And after 2 we are having 4, so we can see that 34 is already before in place, and then it's 4, so we'll write 4, and after 4 we have 55 and 85. So I'll write 55 and then I'll write 85, and in the last we have 66. So this is how we sort these numbers on the basis of ones digit, the least significant digit. So this is the pass number 1. We can complete this, and now I'll adding 0 just before them so that I make sure that these are the 3-digit numbers. So this is the pass number 1. Now in pass number 2, we need to consider the digits at tens place. So now we will consider this 6, here 8, here it's 5, here it's 0, 3, 0, 9 and 6. So now we'll consider these 10-digit places, and now again we'll perform a counting sort and sort these digits. So let's see, based on the tens place, we have this is 6, 9, 0, 3, 0, 5, 8 and 6. So obviously the elements with 0, so you can see 502 and this is 004. So we'll bring this 502 ahead because it's already ahead in the place. So this is 502, then we have 004, and then once we have done with the 0, the next element, the next smaller element is 3. So we'll keep this 034. The next after 3 we have 5, so we have 055, and then after 5 we have let's say 6. We have two options in 6, and this is already before in place, so 160, and then we have 066, and after 6 we have this 8, so we'll have 085, and finally we have this 9, so this will be 090. So this is the second pass we had done on the basis of tens place of the digit. Now the third pass, this will be the last pass, and we'll have the sorted array, and this will be done on the basis of the hundreds place, that is the most significant digit. So now we'll consider the most significant digit and we'll apply the counting sort and we'll sort this. If you are not aware about how counting sort is done, you can watch my video based on the counting sort. So let's do the third pass and obviously the final pass. So in the third pass, we need to sort this array on the basis of most significant digit or hundreds digit. So let's start. We have 0, we have 5, this is 0, 1, 0, 0, 0. Most commonly we have 0. So we'll begin with this. So this will be, because it's already on the left hand side, so we'll start with this. This is 0, 0, 4. The next digit with 0 is 0, 3, 4. Next digit with 0 is 0, 5, 5. Next with 0 is 0, 6, 6. So we have 0, 6, 6. Next with 0 is, we can say 0, 8, 5. So we have done, and this is the last 0. This is 0, 9, 0. Now after 0, on the third place, we have 1. So this is 1, 6, 0 will be the next element. And after 1, we have this 5. So this will be 5, 0, 2. So now we can see this is the sorted array after pass number 3. So this is how the Radix sort is performed. If you will see, after first pass, we already have single digit numbers on their places or an ascending order. We can see this is only single digit number 004. It is that is sorted. And after second pass, we have all 2-digit numbers already sorted. If you'll see, this is 34, then 55, then 66, then 85, and then 90. So this is already sorted. And after third pass, we have all the 3-digit numbers that are sorted. So we have this 160 and 502. So after 3 passes, this array is completely sorted. Now let's see the algorithm. This is a simple algorithm for the Radix sort. So this is Radix sort. We'll pass the array and then we'll pass the size. In the first step, we need to find out the maximum element we had done, so as to identify that how many passes we need to do. Then we need to run a loop. That means according to the number of passes, and inside the loop we need to count. We need to perform the counting sort on the array, and for which the base will be the exponent. So using the exponent, that is, in the first case we'll use the ones digit, in the second pass we'll use the tens digit, in the third pass we'll use the third digit. So this exp will give us the base and this m will give us the maximum number. So this is how the Radix sorts algorithm. This is a simple algorithm. You can go and watch the counting sort video for the detailing of this counting sort. So now let's discuss the time complexity of this Radix sorts with the help of this algorithm. The first step, it's a simple assignment that will take the time complexity of order of 1. This is a loop. Let's say if the loop is running for k times, so the time complexity of this will be k, and this is a counting sort. We already know that the running time of the counting sort is of order of n. So the time complexity comes to be of order of k dot n. So this is the time complexity for the Radix sort. And let's say talk about the space complexity. So if we see that the space required for this first step will be of order of 1. Then inside this the space required for the counting sort, that will be of order of n. This loop runs for the, let's say, k times. So the spaces will require k times. As we can see, the space is required for the first array, then the space will be required for second, then for third, and this is fourth. So basically it's k times that we require the space. So the space required will be n plus k. So the space complexity of the Radix sort comes to be of order of n plus k. So this is all about the Radix sort. In the next lesson, we will be talking about the bucket sort. Thank you so much.